Look at you, one of the faithful, more than faithful, enlightened. You understand that anatomy doesn't end at what our naked eye can see, but if we truly want to understand what on earth those kidney physiologists are talking about, we need to look at the microscopic structure of the kidney, see how it's all arranged, those tiny little tubules, look at how the cells are lined up and mapped out. So that's what we'll do. Sure, the kidney's got a whole bunch of functions, but what we're going to focus on today is its main function of making sure we've got the right amount of water and salts inside us, and it excretes other things as well. So we evolved from animals that evolved in a salty sea. We now carry that salty sea around inside us, so it's crucial that we keep the right amount of water and the right salt concentrations in our tissues so that our cells can operate normally. Here's our kidney. It sees a lot of blood. Blood comes in and blood goes back out again. Out here we've got the cortex of the kidney around the outside, and then we have the medulla, the medullary pyramids, and here these spaces are collecting the urine. So we're really interested in what happens to the blood and the fluids and how they get in here. The functional unit of the kidney is the nephron. Almost kind of a mystical term, right? And what's happening at the nephron? So the nephron is the microscopic unit of the kidney. So the nephron, this is what we'll be looking at under the microscope in a moment. What's going on here is we've got the blood comes in, we have this tiny little arteriole that comes in here. Now the nephron is made up of the renal corpuscle and the renal tubule. Together they make up the nephron. So the renal corpuscle is this first bit here. The arteriole that comes in forms like a ball of a capillary network here, and this is the glomerulus, and then the blood goes back out again through this arteriole here. So the blood comes in, wiggles around this ball of capillaries and back out again. Now this capillary network is a bit special. It's fenestrated, like other fenestrated capillaries, so there are little windows in it, little holes, probably 16 nanometers in diameter, but there are a number of layers here that make up a filter. And through that filter, through those tiny holes and the basement membrane, and we'll see podocytes, cells with feet covering all of this, through this three-layered filter, water can pass through and the right molecules can pass through. So molecules of the right size, so smaller than the pores, and molecules of the right charge can pass through. So this is what we mean by the filtering part of the kidney. The blood is passed through this capillary ball, the glomerulus, and fluid and molecules can pass out, and then they pass into essentially the tubule. So this is the first part of the renal tubule. This gets called the Bowman's capsule or the glomerular capsule, and the fluid is leaking into a space here, and the small molecules are leaking into a space. And then once into the tubule, this is the tubule here, and it's a big long tube, and we give it a whole bunch of different names, or names of its parts, and then eventually at this end, now we've got urine, and it passes into this collecting duct, and the collecting ducts pass into bigger collecting ducts and other ducts and other ducts, and eventually out of the body. But this tubule, you see that the fluid is passing from this end all the way along to this end, which means this would be the proximal part of the tubule, and this would be the distal part of the tubule, and this is very wiggly, so this gets called the proximal convoluted tubule, and this gets called the distal convoluted tubule. And then we have straight parts, we have a loop, the loop of Henle, and we have other straight parts. You might call this a descending part and an ascending part. You might call this a thick part and this a thin part. That's all those terms are referring to. Just like anatomy anywhere else, it's just describing the parts of the renal tubule and the parts of the nephron. And the other thing you can see that's happening here is that as the fluid passes through this tubule, it's surrounded by other blood vessels, other capillaries. So what's happening here is that the fluid and the salts and the other molecules in here have a chance to be reabsorbed back into the blood, back into the body through this tubule before it goes into the collecting duct. Once it's in the collecting duct, it's urine, it's off and away. This is the glomerulus on the large model. So these are the capillaries in here. Blood vessel coming in, blood vessel coming out, blood goes around and out. And can you see, this is the first part of the tubule here, so the proximal tubule. This is Bowman's capsule. And can you see there's a space in here? So it's that space in there that the fluid is filtering out into, and then it passes along the ductule. Now, can you imagine if you have 1 million of these in a kidney, and then we cut thin sections through here, so we're cutting sections through this, we're going to see lots of circles, lots of elongated ovals, we're going to see glomeruli. Let's see what that looks like under the microscope. How are you doing so far? That's most of what goes on. Blood goes in, molecules of fluid leaks out into the tubules, has a chance to get reabsorbed. So here is the section we're going to look at today. So clearly, that's not a human kidney because it fits on a whole slide. We can see around the outside the cortex, and on the inside the medulla. We can see slightly different staining here. Oh, is this Masson's trichrome? Masson's trichrome is one of my favourite stains. And essentially it adds a green stain for the connective tissue. I'm a big fan of connective tissue. Okay, I'm on the lowest power. Let's give it a bit more light. So this is a 4 times objective. I've got 10 times magnification to my eyes, which gives me 40 times magnification. And it's likely to be a little bit different to you, depending on the size of your screen. But out here, we have the edge of the kidney, so we have the capsule. Like I say, the green there is the connective tissue, the collagen. And as we slide in, we're seeing lots of circles, some streaky bits. Let me just check my focus. Oh yeah, that looks good. And oh wow, blood vessels are going to be easy. Looks like this has done an excellent job of keeping blood within the blood vessels. We can see those nice and easily. And as we continue to slide in, see how this layout changes. We go from having lots of circles to these long structures. So these would be the medullary rays. We're getting down into the medulla, so we're crossing from the cortex to the medulla, and we're seeing a lot of green. So we're seeing a lot of connective tissue. And as we continue to slide towards the middle, it's getting quite bright now. Oh wow, that's great. I'm seeing the shape of the pyramid. You're going to get it. There we go. As it comes into frame view. So there's the tip of the pyramid, of the renal pyramid, and all those collecting ducts and papillary ducts are draining to that point, and then we have a space there in the kidney, and that space is the minor calyx. That's where the urine is collecting. That's the overview. Let's go back to the top. Let's go back to the cortex and see if we can see those things we were talking about. I can see some straight away. Can you see them? Okay, let's jump up to the 10 times objective. Does that make any sense to you? Look, can you see? So these, there are some distinctive balls there. Those are those balls of capillaries. That's the renal corpuscle. That's the glomerulus. And we're seeing these dotted around. So there are 2 types of nephrons. There are nephrons out in the cortex, and there are nephrons next to the medulla, juxtamedullary nephrons. I mean, they're not really different types, in different places anyway. I'm going to refrain from doing too much detail, and we're going to spend time looking and describing and understanding, all right? Because the physiologists can talk so much about the functions of the kidney already. Anyway, right, so you see we've got a number of glomeruli here. So there's a nice one. If I jump up to my 20 times objective, give you a load more light. Ooh. 'Cause Very, very pretty, if nothing else. So we're seeing lots of circles around the glomerulus. So these are those tubes running in different directions, and we're seeing ovals. So those ovals are tubes caught in a glancing blow, and some of those ovals are longer than others. So we're seeing the shape of the tube. But imagine we had that proximal convoluted tubule, and we had the distal convoluted tubule, and they're around the glomerulus. They start here and they come back up here as well. So that's what we're seeing there. And then we're seeing things like that, which are very red, filled with red blood cells. So that's clearly a space with blood in it. And we can see other spaces with blood up against these renal tubules. So it's all, that's the reason it looks so complicated, is we've got that structure I was describing at the beginning. It's just a glomerulus, so it's the renal corpuscle and the renal tubule times a million squished together. That's why this looks complicated. But if you remember the single nephron unit, this makes more sense. So if I jump up to 40 times objective, give you a bit more light. So it's a very delicate collection of structures in the kidney, which is why it's susceptible to damage. So in the centre there we have got all those capillaries looping and looping. So we have blood passing through there, and we can see some hints of red blood cells with the pink colours there. And there's an endothelial wall to the capillary, and that's the bit that's fenestrated, it has those tiny holes in it. And there'll be a basement membrane supporting all of this, which is part of the filter. And then we have podocytes, those feet cells that wrap around all of this and also make up part of the filter. You can imagine if you're filtering water, you have layers of stone, gravel of different sizes. You have your big gravel, and then your smaller gravel, and then finer gravel, and then your sand and your charcoal, all those different layers of your filter different sized things out of your water. The same sort of thing that's happening there. Now around the outside, the circle around the outside, that's the Bowman's capsule. So that's the glomerular capsule. And the space between the glomerulus, the capillaries in the middle, the ball of capillaries in the middle, that space between that and the edge of the Bowman's capsule, that's a real space. So that's the capsular space. That's where the water from the blood and the small molecules from the blood, the salts and what have you, that's the space they're collecting in. And that is the first part of the tube. It's just the widened part of the tube, and it will continue as a tube. Of course, we can't see it in this thin plane of section, which is probably cut at about 8 or 10 microns thick. Now that space there, Bowman's space, lined by the Bowman's capsule, the cells of the capsule there, those very flat cells, they're an epithelium. So the renal tubule, all the way along, is lined by an epithelium, and so are the collecting ducts. So that's a simple squamous epithelium, right? A very thin epithelium. And then that is going to pass into the first part of the tubule, so the proximal convoluted tubule. So this is likely largely what many of these circles up against it are, right? So in the proximal convoluted tubule, this is the part of the renal tubule where most reabsorption of water and useful things, some of the salts and the other molecules, this is the first opportunity that the body has to take back those things that it still needs right now. So the proximal convoluted tubule is where a lot of the reabsorption occurs. And in the proximal convoluted tubule, if we get a clean one, I mean, these are pretty good. You can see lots of granules in the cells. The cells here are epithelial cells. They are now more cuboidal shaped. So this is and it's a single layer. So this is a simple cuboidal epithelium lining the proximal convoluted tubule, and they have microvilli. So the cell membrane is folded up into microvilli, and that gives more surface area for that reabsorption. and also for putting things into the urine. The more cell membrane you've got, the more things you can pass between the cell and the cell membrane. So that's, have we got a super clean one? Maybe. Those are pretty good, right? So we've got our glomerulus, we've got our renal corpuscle nestled up against some tubules, and actually you can see the difference there. You can see that some of those tubules are really pink stained, they've got loads of granules in them, and some of those tubules are not, some of the cells in the tubule are not very pink stained, they don't have very many granules in them. So what we're looking at here, we are looking at the contrasting proximal convoluted tubule, the first part that's going away from the renal corpuscle, and we're seeing the distal convoluted tubule, the last part that's made its way back up against the renal corpuscle and is about to send the urine into the collecting duct. Let's zoom back out a little bit. Now, the proximal convoluted tubules are longer than the distal convoluted tubules, which is why it looks like there are more proximal convoluted tubules than distal convoluted tubules, if you see what I mean. There's more wiggles of the proximal convoluted tubule, so we keep seeing it as it comes through the plane of section, whereas the distal convoluted tubule is shorter. But you can see there that the distal convoluted tubule, it comes up and it touches the glomerulus. Here we have what's called the juxtaglomerular apparatus, which makes sense, juxta next to the glomerulus apparatus. What's happening here is, so why the distal tubule comes all the way back up here is so that it can interact with the renal corpuscle. So depending upon what's running through, what the fluid is in the distal corpuscle, sorry, in the distal convoluted tubule at this point, what's in there, you know, what's been reabsorbed and what's been put in, depending upon the contents of the distal tubule as it passes the renal corpuscle, that will then affect the blood flow through the renal corpuscle, which will then affect the filtration rate of that nephron. And that's how the kidney regulates its own filtration rate. It will also regulate systemic blood pressure. So there's an interaction there. The cells then are making an interaction based upon the fluid that's passing through the distal tube and then the activity of the renal corpuscle. Oh wow, it's all so confusing. So if we look around the cortex, this is what we see. Lots and lots of renal corpuscles, lots and lots of proximal convoluted tubules, and lots of distal convoluted tubules, lots of blood vessels. Look at those, look at that lovely shape in there, right? Look at that, that's a good one. There we've got a glomerulus, and we can see the arteriole coming into it or going away from it. I mean, we couldn't tell which way it's going, right? And there's your renal corpuscle, so there it goes in and then wiggles around in the glomerulus and then back out the other side. Of course, we can't see it coming out the other side because we haven't got the 3D picture. We've only got a 2D section through it. But it's that tiny blood vessel that is having its flow controlled to control the filtration rate of the nephron, to control the blood flow through the glomerulus. And there we're getting to the surface. But that's what the cortex looks like then, that's what that's like. So imagine the cortex, you've got your renal corpuscle, you've got the tubule starts, and then it descends off down towards the medulla, doesn't it? So if we slide slowly towards the medulla, look at that blood, look at those tubules, and now as we're sliding towards the medulla, we're starting to see tubules running in that direction towards the tip of this lobe of the kidney, of this pyramid, right? So what we're seeing here then is we're seeing that the descending part of the tubule, and we're seeing the thick part of the descending part of the tubule and the thick part of the ascending part of the tubule. It's going back up to the cortex. This is lined by an epithelium. So now we're seeing tubes that are lined by that simple cuboidal epithelium. Now if we see these tubes thin, like we do here, now we're starting to see the thin parts of the renal tubule, right? The thin part that loops around as the loop of Henle. So we're going from a simple cuboidal epithelium to a simple squamous epithelium as this is thinning. And the cell shape is changing because the functions of the renal tubule are a little different as we go along. But I am not going to describe all that. That's for the physiologists, right? And in fact, there will be lots of blood vessels in here if we were to look carefully. So there's lots of blood vessels in here because the fluid, if it's going to go anywhere, it's going to go back into small blood vessels. Remember, because we're looking at a particular plane of section, we're seeing some things and missing other things. We're not seeing the whole three-dimensional picture here. However, did anybody work all this out, right? And then as we go down towards further down the medulla, we are seeing collecting ducts. And the collecting ducts will become larger and larger, just like streams flow into rivers and rivers flow into bigger rivers. The collecting ducts get bigger and bigger, and we have papillary ducts. And again, we can see these will be lined by, in humans, these collecting ducts will be, this is a bit bright, isn't it? Sorry. In humans, these collecting ducts will be, they'll be lined by a simple cuboidal epithelium, but that epithelium will get taller and taller as the lumen of the tube gets bigger and bigger. So it will become a simple columnar epithelium. Let's see if we see any of that as we go towards the tip. We don't here in this animal. But that's something you might expect to see in the collecting ducts and the papillary ducts, a simple columnar epithelium, so a single layer of taller cells. But that's our tip. That's where then all the urine is collecting in that space there. So I'll show you the path we just went down. So there are those collecting tubules, these medullary rays, so the medullary rays are a mix of collecting tubules, of blood vessels, and the renal tubules as they extend down into the medulla. But you can see a clear demarcation, right, where we go from medulla and up to the cortex, and look how there are so many more blood vessels further out here. And this is why it keeps catching me out with the brightness, right? I don't know about you, but I have to simplify this down if I'm going to get to grips with it and have any hope of understanding it. So arteriole comes in, ball of capillaries, arteriole goes out, fluid leaks into essentially the Bowman's capsule, the Bowman's space. Now it's in the renal tubule. Wiggly bit of tube at the start is the proximal convoluted tubule, so we're going to see that up against the renal corpuscle. And then that proximal convoluted tubule will eventually descend down into the medulla and then loop around. Oh, is that a loop there? Look at that, that's a loop, isn't it? That's a loop. We caught you looping. So that's the bottom of the loop of Henle there. And loops around, and then it comes back up again into the cortex. So now it's the distal tubule, because it's the end bit, it's further away from the start. And then as it gets back up here, it gets all wiggly. That's why we're seeing this shape, is because instead of going back up, now it starts wiggling. We get the distal convoluted tubule, and it comes back up to the glomerulus, presses up against it to regulate the flow of blood through the renal corpuscle, thus affecting the filtration rate of the nephron, and then it goes off and finds a collecting duct up here, which might be some of these tubes here. And the collecting duct then takes the urine back down, wee down. Oh, those blood vessels, those are cool. Past those, down into the medulla, and all the way down to the tip where urine is deposited into the calyx. That's it. Just do that a million times over and you've got a functioning kidney. How are you doing? Keep it simple. 2 parts of the nephron. Add the physiology on top. Add the detail on top. Wow, it's hard to teach and hard to learn. I feel a bit better now after, because I haven't looked at the microscopic structure of the kidney in years, but I feel a bit better anyway. All right, see you next week for some more fascinating microscopic anatomy.